Hi, class. We're going to look at the scientific method today and talk about why the scientific method is a better approach in doing psychological research than just using our common sense. So what are we going to have to know after we watch the video today? Well, I'm going to put some words, important terms down on the left side of your screen that you want to be able to not only define, but to be able to use in an explanation when we talk about scientific method. And how do they relate to psychology research that we'll talk about as the unit continues. Make sure you slow down a little bit and take notes as you go along, and be sure to highlight and look for highlighted terms in the video. Those are going to be important for the AP test as well as just for your knowledge. And be kind and rewind if you need to. You can stop and pause and go back if you need to look up another term or look at an example that we spoke about before. So we're going to get started, and we're going to talk about a couple terms right away, parsimony and the scientific method. So let's introduce the scientific method. And a lot of you know what this is already. You've had it in science class before. Basically, the scientific method is a standardized way of making observations, collecting data, forming theories based on those observations, developing hypotheses, and running research, interpreting the results of that research. So it's a very specific step-by-step process. And we usually start out with a theory, and a theory is an explanation that organizes a lot of separate pieces of information into a connected and coherent logical way. So it's very precise and very standardized as opposed to common sense. So let's look at an example of a theory and show how it may work and how we might develop it. Let's say that a college professor observes that some sophomores have blonde hair in his class or her class, and others have brown hair in class. That's one observation. Another observation is that most sophomore couples that he or she sees, at least one person has brown hair. In addition, he notices in other observations that his friends who have brown hair date regularly or date more often, while his blonde-haired friends don't seem to date much at all. So how does he explain these observations? He develops a theory. Now, a good theory does two things. One, it organizes a lot of different observations into a logical way, into a statement, and it allows the researcher then to come up with predictions about that theory so we can check it. That's how we develop hypotheses. Now, a good hypothesis is a specific statement of expectation of what's going to happen given certain conditions. For example, given certain variables and certain procedures together. We can often put this into an if-then statement when we use our research. Then after, let's say we develop a hypothesis, if college sophomores have brown hair and go to this party, they will make more dates than college sophomores who have blonde hair. So if they have brown hair, they'll have more dates than if they have blonde hair. So then we make observations. We gather data at this party. We see who seems to be making more dates. And as we make these observations, if we don't see what we think we were supposed to see, if the blonde-haired people are making more dates, we're going to have to revise or refine our theory. If the data supports our hypothesis, then we can make conclusions and develop certain confidence levels. So we've got all these people going to this party. We're watching all these people interact, and we're going to make observations about those people and either accept our theory, our hypothesis, or we have to refine it and do it again. Okay? So know that process, scientific method. So some other key factors about psychological research and the scientific method. Research has to meet some very specific criteria in order to be scientific. First, the research must be replicable, which, as you probably can guess, means what? Repeatable. Why do we want to replicate data? Why do we want to make it replicable? So other researchers, our peers in the field, can review it and replicate it and see if the results are the same. The only thing that might be different is the subjects. So in order to do that, a very important process is operationalizing. So we want to describe in detail how we made our discoveries, how we did our observations, how we set up the research. So if it's replicable, we can publish and have others repeat it. And research also has to be falsifiable, and not a lot of people consider this, but we have to be able to prove it false. And if we can't prove it false, then it doesn't stand up to the scientific method. So we're probably not going to study ghosts, we're not going to study aliens, and we're not going to study if the Loch Ness Monster is real, because people can just say, well, those creatures only present themselves to people who believe in them, and if therefore you don't believe in them, so they won't show themselves. Well, we can't disprove that, because people just say, well, you don't believe in aliens. So we're not going to study information or phenomenon like that. And we also want to be able to avoid something that happens to all of us. It's called confirmation bias, or a tendency to look for information that confirms exactly what we expected in the first place. So we have to be careful not to only look at that type of information. So we have to be able to find information that's falsifiable, that proves our theory wrong as well. Let's say we're the Loch Ness Monster. People say, well, the Loch Ness Monster is so intelligent that it can hide in undiscovered and undetectable underwater caves. Well, that's not falsifiable, because we can't disprove undiscovered caves and that monster is supposedly smart enough to hide in it. So it's not a real theory. Now, research also has to be precise. By stating our hypothesis very precisely, researchers can then replicate it in order to ensure that the data is accurate. And we want to be able to use operational definitions in order to do that. An example might be, let's say we're doing an experiment to see whether toddlers are happier when it's warm out or when it's cool out. We have to operationally define what we mean by happiness, so we can measure it precisely, so other people can use the same measurement method. We also have to operationalize what's warm versus what's cool. And we might operationalize happiness by a number of smiles per hour. So we're counting smiles. That's replicable. We also, basically we're creating like a recipe. So we want to follow a set of clear instructions, like we might if we're making chocolate chip cookies, and we use the same process and ingredients. And if we follow that procedure the same way and we get the same results every time, we've probably got a pretty good research method going on. So research also has to be parsimonious, which means being simple and stingy. We don't want to be exorbitant. We don't want to be illogical. We want to keep things very economical. It's like pinching pennies. We wanted the simplest explanation possible when we're doing our research. Also referred to as Occam's razor. I've seen this on the AP test before, so make sure you know this. It's using the simplest explanation for any set of observations is usually probably the best. So think razors here. It's very thin, very precise. And it prevents us from making outlandish theories when we see things. An example might be, let's say there's a student that consistently falls asleep in class. And this student theorizes that before each class, I sneak up to her desk and I spray it with some special undetectable nerve gas that makes her drowsy and falls asleep. Now, if we're applying the principle of parsimony to her theory, she couldn't come up with this theory because we can account for her sleepiness in other ways. Maybe she stayed up late texting her friends. Maybe she had an away basketball game last night and didn't get home till midnight. Maybe she's just bored with class. All those are simpler explanations, more parsimonious, so that's what we're probably going to use to explain the data. It's not like, well, I don't know why somebody behaved the way they did, so therefore it must be due to aliens. That's outlandish, and we often come up with theories like that when we don't have a logical explanation, but in research, we want to look for the simplest explanation, not the most outlandish and crazy one. Think about this in your own life and how often you come up with outlandish explanations when there's probably a much more simple explanation. So what we want to do now is we're done with this information, so you want to review, look at these terms. Can you define them? Can you connect them together in a logical, simplistic way? And can you use them to explain a set of observations and judge whether research was parsimonious or stingy, or was the scientific method used? Then you can judge research as being scientific or not. So that's it. Be kind and rewind, and we'll be ready to explain and discuss these terms in class tomorrow.